All right, let's go ahead and get started. So hello everybody and welcome to DZone's webinar presentation today titled How to Introduce Telemetry Streaming in Your Network with SNMP with Telegraf, brought to you by Influx Data. I would like to introduce you to our presenters. First, Josh VanDeraa. Josh is a network automation engineer with Network to Code with over 20 years of experience within various networking practices. Josh has focused on network automation over the past 4+ years with Python and Ansible to deliver on daily and project-based tasks. Josh is always looking to improve the IT environment and networks and to get the right data in the right system at the right time. I'd like to do a quick sound check for Josh. So Josh, please say hello to our audience. And audience, let me know if you can hear him by posting a message into the chat panel.
Hello, good afternoon, good morning, good day, everyone.
Perfect. It looks like they are able to hear you, Josh. And now I would like to introduce our second presenter today, David Flores. David is a senior network automation consultant at Network to Code, focused on software development and automation practices for the net DevOps world. David is an experienced networker and service provider in data center fabric infrastructures. At this time, I'd like to do a quick sound check for David. So David, please say hello to their audience, and audience, let me know if you can hear him.
Hello, good morning, good afternoon, good evening.
Perfect, both of you sound loud and clear, and I'd like to pass it over to Josh and David for the presentation.
All right, thank you for joining us. Again, this is how to introduce telemetry streaming with GNMI into your network with SNMP and Telegraf. So first off, who is Network to Code? David and I both are consulting engineers with Network to Code. We were founded mid-2014. We're a network automation solution provider, and that we really focus on automation, programmability, and taking a look at what we can do to reduce inefficiencies. We are a services only company, and we are vendor independent. So when we take a look at things, we aren't just a Cisco, Juniper. We will work on pretty much any gear. Cisco, Juniper, Arista, HPs are just some of the examples. We work with open source tools, Ansible, Python, StackStorm in their Telegraf, InfluxDB, Prometheus, Grafana. Really, if it's an open source tool to help us deliver on our model for helping bring DevOps to the network organizations, we are more than happy to take a look at it and use it. So IT operations software that we have experience with includes ServiceNow, Remedy, IBM, and you can find us on the web at networktocode.com, on Twitter at networktocode, and as well on LinkedIn. So just a real quick couple other things about us. So for me, I'm based out of Minnesota in the US. Been working on automated networks since 2015 and using Telegraf since 2018, really, for many things. And I'm on Twitter at VanDeraa and many other places than at JVanDeraa. David?
Hi, yeah, I'm based in Dublin. I've been working on automation since 2013, and yeah, been Telegraf newbie actually since last year. So I still consider myself a newbie on the Telegraf world. Happy to be here.
So agenda, what we're going to kind of look at is the network streaming telemetry stack. We're going to take a look at GNMI, what that does for us, what the value is there. Gathering data from network devices with Telegraf, so that we're going to take a look at both GNMI and SNMP in there. And then really the part that really helps and drives further is how do you enrich and modify those metrics that we gather. We'll have a demo, and then we'll wrap up with some tips and tricks and a couple other small housekeeping items there. So when we look at the telemetry stack, we take a look at the top of, we have network devices, we want to collect information, enrich that information, store it, and then provide it some sort of dashboard capability to understand what the metrics are that we're seeing. So GNMI and streaming telemetry, what is GNMI? It's a model-driven configuration and retrieval of operational data over gRPC. So that's RPC is remote procedure calls. G is involvement with Google. It uses protocol buffers, so we get some incredible operational efficiency over the network of sending data. And the biggest thing about this is a subscription model, meaning that we have an agent that sits somewhere, it goes out to the network device and says, I would like to gather this particular information. One quick note, we'll get into plugins and what it is, but previously this particular plugin was called the Cisco Telemetry GNMI plugin. In Telegraf 1.15, it did migrate over to being just GNMI with the support of multiple vendors. As I look back at the original GitHub issue about the proposal, every network vendor that I saw on there, Arista, Juniper, etc., all were on board with, yes, this works for GNMI. Let's go ahead and rename this and keep using it. So now, where does Telegraf fit in with gathering network telemetry? So first off, what is Telegraf? Telegraf is a plugin-driven server agent for collecting and reporting metrics, and it's written in Go. With it being written and compiled in Go, it's very quick and very efficient. Natively, Telegraf will pull metrics from the system Telegraf is running on, but also it will go ahead and reach out to third-party APIs, such it can go to native APIs on the web, or also via what we'll see coming up, SNMP and other gathering metrics from network devices. It provides the capability for processor plugins to enrich and normalize the data for us, and then output plugins to send it off to various data sources. So it's really the gatherer of it, goes out, gathers information, and then sends it off to be processed and used elsewhere. So the configuration that we'll have, this is GNMI. We see that we have our inputs, we define our addresses in the top, and then we have a username and password. Pretty straight to the point for that. And then we start to have a list of subscriptions. So in this case, we have a single subscription that we're looking to get the interface information. We have our subscription mode of sample, and we're going to sample that interval every 60 seconds. So we're going to request that we get this data from the device every 60 seconds sent to the Telegraf agent. So we have this particular network. We'd love for everything to collect with streaming telemetry, but streaming telemetry is still relatively new in the age. We may have some devices that they don't support streaming telemetry. So are we unable to use it? Thankfully, we look at the concept of hybrid collection. So with hybrid collection, we're going to get GNMI from the devices that support GNMI because there's efficiencies gained from a subscription model and it is able to be processed faster. We'll take a look at that a little bit later. But we can also take a look at SNMP then. SNMP has been around since the 90s, so it's been around for quite a while. The configuration is a little bit more. We have our agents about which devices we want to collect SNMP data about. The version, this does support SNMP version 2 and version 3. So this isn't, we show the version 2 because it's a little more concise. And then we get the SNMP community. How often do we want to pull the network device? What the timeout is in retries. So digging down a little bit further, and with SNMP, you do have to dig in. We have the first field where we go ahead and say we want to get the system name, so that way we can use a tag coming up of host name. And then the next thing we want to get is all the interface statistics from the extended counter. So we pull for the IFX table, and there we have inherit tags of host name in the middle. So that's why we went ahead and pulled for the host name originally. And then we want to go ahead and set more tags about each polling. We want to know what the interface description is to have that as a tag as well. So with SNMP, Telegraf is able to do everything that GNMI can do, and then we'll take a look at how do we put these all together. So the challenge that we have with these multiple import plugins, when we take a look at the Influx Line protocol where we have the measurement, tag set, field set, and the timestamp, with GNMI, in order to get the interface inbound and outbound octets, the actual counters that are increasing, we get two different measurements coming back. We have the interface for the measurement, we have the source, we have the name for tags, and then we have the actual field and the timestamp. SNMP, we get a little bit of that same data, but we take a look here that the interface out octets looks much different than the out octets on GNMI. So how do we handle that? Well, with the Telegraf Pipeline as aspects of things, on the top, we've got SNMP and GNMI where we're collecting information. Take a look at the Telegraf documentation. There's over 190 available input plugins. Then going down the pipeline, we then get into regex and rename. So this is how we enrich the data. So there are 25 processors available, and more. They keep on increasing. And then lastly, in this pipeline, we're going to have example of sending out to InfluxDB, and you can send it to Prometheus, out to a file, many other places. So the enrichment side of things, we collect the data, and then we add device level tags at the top with collecting. Then we want to normalize the data. Oftentimes then we'll use rename to change the various components to match into one particular set. And then we use regex module to help us to enrich the data with such as adding an interface role, like if the interface on one switch is going to a leaf or if it's going to a spine type thing. And then lastly, we send that out, the output plugin sends the data. So an example of the rename, we're taking the field of interface HC in octets, quite the mouthful, and we want to change that field to the destination of just in_octets, and then the same for the out octets. So that's right there is how you would get this to match what's on GNMI. And then we also had the tag agent host was coming in on agent host, and it was sourced on GNMI. So once again, we'll take what is done in SNMP and then change that over to a source. Then the piece about how do we add metadata. So this is an example of a processor for regex where we're going to apply the rules that we want. First item there is the tag pass, where we will say we want to only send the host device one, so you can have all the devices that you want to send through this processor. And then when we see the interface name of GE000, we're going to go ahead and add the key of interface role with with management as the tag. Oops, that one backwards on me. And then secondly, we're going to say the gig001 on the second pattern there. We'll say that we're going to take and create the tag interface role and send that off to data. So with that, I'm going to go ahead and hand this over to David to get into the demo.
Okay, can you see my screen? Yeah. So yeah, so the demo that I'm going to show is basically all the data pipeline configuration that Josh just presented in slides before, right? So for this demo, I have a couple of virtual routers. We have router 1 and router 2. One is a Cisco iOS router, the other one is an Arista router, and they have configured, one is configured with SNMP to collect the data, and the other one is using GNMI to collect the data. I have a couple of Telegraf instances that are monitoring. Telegraf R1 is monitoring router 1, and Telegraf R2 is monitoring router 2. Now, on the background, I have 2 more instances that started like a while ago to collect the data. So when we go to the presentation phase, you have a better visualization of of some traffic in the interfaces. And actually, on that point, the metric that we're gathering for this demo is interface metrics. Okay. So from an SNMP point of view, we will be gathering the interface IFX table. And from a GNMI standpoint, we'll be gathering the OpenConfig interface path down to counters, okay? All the data is going to be stored in InfluxDB. And then we're going to use Grafana to do the visualizations and see the benefits of having the data normalized and enriched, okay? A couple of items here is that the demo, the whole idea of this demo is that I'm going to start changing the configurations on the different sections of the data pipeline process of Telegraf, and you will see in real time how those fields are changing. Okay, so you have a better feel of how that looks in real time. So right now, what I'm showing here is the example snippet of Telegraf-R1. Telegraf configuration is based on TOML. Okay, that's an acronym for TOM, Obvious Minimal Language, and it has 3 major sections. It has a global tag section where you actually have some key value fields that you can set onto your metrics as an extra metadata. In this case, I'm specifying an extra tag called device role and the value for this device, which is a spy, okay, in my topology. Also, you have the agent component. The agent component is normally used to handle the configuration of the Telegraf instance per se. So in this case, I'm just statically putting the name, the host name of the Telegraf instance to Telegraf-R1. Because by default, these are containers, so they would use the container ID into the metric. So in order to make it more meaningful, when I do queries on top of this data, I'm specifying the host name. Now, the third biggest part of the Telegraf configuration are the plugins. And the plugins are input plugins, processor plugins, aggregate plugins, and also output plugins, right? From input, we're gathering the SNMP input here. I'm specifying what device I'm going to collect. You can see that I have here set R1. And you can also see that this is like an array, and we can put multiple devices here for the collection. I'm specifying SNMP version 2, and I'm also using an environment variable called SNMP community in order to be passed for the plugin. Okay, so this is another nice feature that Telegraf has. You can actually pass environment variables for sensitive type of data. Also, I set up the interval of up to 60 seconds for SNMP, and the timeout and the retries is well, we have issues connecting from the agent back to the device, right? Now, here is where I started specifying how I'm going to collect the data. So basically, on SNMP, I specify a table. I'm going to collect a table, and this is going to be the OID. Okay. Now, I want this to be a specifically named interface. So the measurement, when it's actually pushed, in this case to InfluxDB, is going to be named as interface. So this field is really useful to match whatever policy or when you think it would be better, it would better represent the metric that you're actually collecting. Because if not, it will try to collect whatever information you have on the OID. The field you have, this is a specific field of this table, which is the IF description. I'm marking it as a tag. So instead of actually putting that into a field that I'm going to use for as an endpoint for values, what I want to do here is to actually change this into a tag and rename to basically name. So whenever we're actually looking at that metric, specific metric, we're going to see that the if description field now is being named as name. Okay, so actually here I'm doing a little bit of data normalization in this case. Okay, now the data output for, as I said, the idea is that to show you the life cycle of by restarting the components of the different containers. This container, which is for the demo purposes, is actually sending the data out to standard output, and I'm using the influx data format. Okay, that basically is the line protocol. Okay, so that's Telegraf-R1, and let's take a look really quick on Telegraf-R1, the logs, because it's already collecting some logs. So we can actually see here, this is the measurement, and you can see that the measurement name is now set up as interface. All the values over here are classified as tags, and we have, for example, the device role that I showed you before is specified over here as a tag, okay? And specify the host name as host, which is Telegraf-R1, and also the interface description field is specifying as a name here, okay, which is the interface name. Now, the next part of the Influx Line protocol will be the fields. And in SNMP, is all the counters that you get from an interface on the AFX table are going to be fields. So I have the out octets, multicast, broadcast packets, all that. And at the end, I'm gonna have the timestamp, okay, specifying and the correct timestamp. Now let's take a look on how this, and this is the configuration without any kind of data normalization. This is what I get out of the input plugin, okay? Now let's take a look on the GNMI side of things. On GNMI, you can see that the global and the agent tags are modified the same way that I did on Telegraf R1. Now on GNMI, I have specified the way that I specify the targets is with addresses field, and the same as SNMP. This is an object, and I can specify multiple devices here to be collected under the same input. And then I use username and password, which are the credentials to connect to the device, and a redial option in case we have some connectivity issues to the device. Now, GNMI is a subscription. It's been on a subscription basis. So I'm naming the measurement that I'm going to collect for this specific subscription as interface. And I'm specifying the origin to be used using the OpenConfig interfaces. Now, the path that I'm going to use to collect the counters information is this one, interface state counters. Okay, this is really dependent on the vendor and also the implementation that you have based on the YAML models that you have specified on your network devices. In some cases, you need to do one RPM install in order to get all that information and retrieve the GNMI data, the data through GNMI. But in this case, I'm using Arista, and by default, I can use this path. Okay. The subscription mode, as you said, so we have different set of subscription mode. I'm using sample. You also have on change, which is really useful when you have event trigger based values that you need that only change when an event is actually triggered. And you have target defined that is actually reliant on the vendor implementation. So you're basically letting the vendor decide which kind of method they're going to use to transmit on the subscription. So if you set target defined, and for that specific leaf is like a counter, the metric that you're getting out, then it's going to set out as a sample. If it's more of an event trigger based counter, then it's going to set it on change. Okay. And I'm specifying the sample interval in this case to be 5 seconds. Okay. And the same as with SNMP, the configuration is set up to standard output in order for us to see it, and the data format is Influx DB. So if I take a look on R2, we can see here that the same way that I have on SNMP, the interface is the name of the measurement, and the device role is the global tags. So all of these are tags, okay? You can see already that the name of the device is set on the source field, while on SNMP is called agent host. So there's some discrepancies there. And also, and this is the fields, right, that you get. Now, the difference a little bit, you actually see right now the difference between the data sets of SNMP and GNMI. One key thing here is that on SNMP, you're getting all the counters from an interface, and you're setting up on the same timestamp because it's basically doing the get bulk or walk in this case to get all those counters and then send it over. In the case of GNMI, it's sending counter by counter. So all the counters of that interface have their own timestamp. So that's why you see different lines on the GNMI basis. Okay. Okay, so let's start with some data normalization. Let's try to fix this a little bit. Let me go to R1. I'm gonna enable the rename. Okay, and let me go to R2 as well. And I'm gonna apply the rename. Okay, let's go through the changes here. So on the rename, what I'm doing is basically changing some of the SNMP fields names to their counterpart in GNMI. So IFHC in octets to in_octets, and out octets to out octets, and agent host, and renaming it to device. So it's actually not going to be GNMI specific. GNMI has the source. I'm just calling it device. That's more on my data model. I actually want to see device on my graphs instead of source. Okay. And on Telegraf R2, I have rename only to the source to be set up to device. All the other fields are going to stay up the same. Okay. So let me do reloading R1 and R2. Let's take a look on R2 first, because it's GNMI, so GNMI sends the data a lot faster than SNMP because of the polling interval. So actually here you can see that there is no more source on the device, on the field. It was source equal to R2. Right now we have device equal to R2. So that means that GNMI is already changing, the processor rename is already changing that field value. So that's great. Let's take a look on R1. It should be good. Yes, so on R1, we can see that it changed agent host back to a device equal to R1. So that means that when we actually start looking at querying the data, we know that device in octets and out octets are going to be the same regardless of the device. If the data was parsed with SNMP, or if the data was parsed through GNMI, they're going to have the same, right? Okay, now let's take a look on the data enrichment. So for data enrichment, what I'm doing here is basically applying some rejects. Okay, so I'm specifying that I want to apply regex to the interface measurement, and what I want is to based on the field that is equal to name, I want to parse the value, and with this pattern, and it's going to generate a resulting key, which is another field with value of management. So basically, in my lab, I have a couple of devices. I have 00, 01, 02 interfaces, and I'm specifying a role for those interfaces. Okay, so that's more for my NOC perspective in order how to correlate the data later on. And on R2, I'm doing the same thing, but in this case, this is an Arista device, so the regex pattern is a little bit different. We have management, we have Ethernet 1, we have Ethernet 2, and the idea is that they're going to create a new interface role field with the respective value. Management, spine, backbone, okay? One thing to note here that I didn't mention before when I was explaining the overall topology of the demo is that R1 and R2 are actually connected between each other on the spine level, on the spine link. So I'm going to generate some traffic over there as well to see how that looks like. Anyway, let's apply these changes basically. I'm going to start with R1. Takes a little bit more time than R2. Okay. And this is going to be R2, but in this case, what I'm gonna do is this. I'm going to, one thing that I didn't mention is that the way that this works on the plugin systems is that, well, this is a list and it's going to try to match all these values and see if there is a match. If it's not a match, then nothing is going to happen. One thing that is good when you're actually looking at production is that you have a default value or a default processor here that can actually set up interface role as not assigned, for example. So all the data sets actually look the same when they are in your backend system. Okay, in this case, InfluxDB. And the same goes with the information that you have for the fields of SNMP and also the fields on GNMI. The idea is that you have a data model that maps a one-to-one relationship. Right now, we only care for demo purposes in the RX and the TX counters, but you also care about broadcast, multicast, errors, and so on. So then that was important to highlight. Let's take a look on the interface role. Great. Now you can see that the last processor that I enabled on R2 added the interface role. Okay. So for example, in my Arista device, the interface Ethernet 2, I set up Ethernet role lost to backbone. Okay. So now I have enriched the data on R2. Let's take a look on R1. Okay. So on R1, you can see that it's also doing the same. The gigabit Ethernet 00 is actually interface role set up to management. So we can see that both the data normalization and data enrichment is happening at the moment. Again, in production, it would be ideal to have a one-to-one mapping to all the fields that you care about on your data sets when you're actually sending that data to InfluxDB. Okay. So I think that's important to highlight. Okay, now with that done, I'm going to show you a little bit of how that looks like in real time. So this is Grafana, and I'm using, as I said, Grafana to visualize the data that I have on InfluxDB. This is just a simple interface traffic panel. The top values is basically the RX count, the RX traffic that I have on different interfaces on all the devices, okay? And the ones that are negative is basically just a multiplier by -1. This is entirely personal choice. That way I can see the relationship between TX and RX in a simple graph. And also break down the interfaces, right? We can actually start looking at some of the fields. So for example, the device here, the variable, is based on the device field that we change during the denormalization process, right? So I can actually say here, if I want to see only the traffic on R1, it's changing the traffic to R1. I can see all the RX and TX traffic happening over here, and it's highlighting both on both devices and all the and all these interfaces. If I want to specify, now thanks to the enrichment part, we added interface role. So I can actually specify, hey, show me the management, okay? So it's only showing me the management, okay? And that's because thanks for the enrichment that I did with the regex part of Telegraf, okay? We can actually do a couple of things here. We can set up 2 roles, basically, which is normally useful when you're doing troubleshooting different, let's say you have a spine, leaf layer in your data centers and you want to monitor the north southbound traffic, east west is also really good to have this kind of labels in your traffic and in your measurements. So whenever you are actually looking at Grafana, you see issues, where the traffic's actually going, stuff like that. Okay, now this R1, let's take a look at R2. Well, R2, you can see the difference really quickly between the traffic that on R1 and R2. R2 is really verbose, and that's because if I actually look at on the last 15 minutes, that's because the data points has a lot more data precision. GNMI is streaming the data, so we have a lot of more data to catch traffic out, burst of traffic, and also faster detection of errors or when the traffic goes down. And actually, to make this a little bit more interesting, I'm going to do generation traffic. Well, it's not the best way to test traffic, but it'll do. Okay, so this is generating traffic. This is checking the traffic. Let's take a look on how this looks on SNMP level at this resolution on the last 15 minutes. You can see that the amount of time should be around 1 minute each data point, which is the data interval, okay? And you know that the limitations around SNMP is comments a lot on how frequent you can actually pull the data. It depends on the CPU processor that you have on your target device, and also the overhead that you set up when doing these kind of polls to the network and to the router or switch. And the same goes, and while on GNMI it's more like the client is streaming the data, right? So this is happening right now. If I actually change to R2, and let me put both of them, we can actually start seeing here some traffic. Now let's change it. Let's put a spine actually, so we can see the traffic that is between the spines. Now you can clearly see that the one that has a lot more detected the change or the burst in traffic on the spine links was actually, well, the GNMI output, just because of how much data points we're collecting. SNMP is getting there. He's looking at, hey, there's some traffic coming on, so I'm adapting and doing the rate calculations in order to set up the graph. Okay, so yeah, and actually let's take a look on only this, and yeah, you can clearly see the difference between the traffics in TX and RX. Okay, now this for R2 and for R1 is more, we have to wait. Okay, so one of the good things that GNMI brings to the table, and I think this is really important a conversation of this session, is that verbosity and the data precision and the whole thing that GNMI brings to the table, because you have a better resolution, especially for detecting outbursts and also detecting, drops on packets and errors. And yeah, so basically that. And yeah, I guess with that, I'm finishing up here. So I'm gonna give you back. I'm gonna give control back to you, Josh. Let me. Oh, yeah, change presenter. Yeah.
All right. Thank you. And I think we're back. So with that, from a recap perspective, we've collected data from devices. We went and normalized it so that way that we have consistency. We've enriched the data so that way we could put this all in one single graph. So if you didn't have this enrichment, you would end up having to need to have a graph for SNMP and a graph for GNMI. And by being able to put everything in one place, you're able to get to the data all that much quicker. We had the output go to a particular database, and then we set and got the dashboard. So what's next, and tips and tricks for us? So what are we going to be trying to do next at Networked Code? We're going to be taking a look at the Flux language that was introduced recently for InfluxDB. That goes right along with InfluxDB 2.0 that came out just within the past few months. The other very interesting thing for us is InfluxDB IOX, and so we'll be taking a look at that a little bit further. And then continue to look at the additional plugins. Both input and processor plugins are really interesting to us. And of those, one of the items where Networked Code, we have code in there, is the Starlark processor. So this is a processor that basically is like a Python. It looks very much Python, and it is more or less an executable for us to be able to manipulate data very quickly. And then some of the tips and tricks that we've kind of accumulated over the time here as we've worked with Telegraf. First and foremost is automate configuration with templating and variables. So this might be a good place for Ansible. If you're using some other automation engine, Salt or Python or whatever it happens to be, Terraform, try to look to see if you can use a templating language to help to create all this configuration for you. We saw David working with this and running in Docker. So by containing it in Docker and having a Docker image, you can get yourself a consistent image. And that goes along with the third bullet of installing SNMP MIBs locally. So when we put our packages together with Telegraf, if we're doing a Docker container, we'll have a separate container just for installing those SNMP MIBs into it. The files output that we saw with David is very handy for troubleshooting. And so by files, standard out is a particular file, which means write it out to the screen. One of the other things is SNMP, GNMI. If you aren't able to get the data, but you can get at it in some way, look at writing your own executable. Exec and execd plugins are both very good plugins to write your own code and put it into the Influx query language or the Influx measurement language and send that on over. The input internal plugin, if you're having some troubles, is the plugin to tell you about what's happening with Telegraf. And then one of the big things, if you're running a device that supports Linux and you can run Telegraf natively on the device, definitely take a look at running Telegraf on the device. Such things like a Cumulus Linux will have, it's a Linux OS running on a network switch, so you can go ahead and run Telegraf at that point on those devices. Take a look at the other vendors there as well. And then look at reachability plugins. So network response, DNS, you want to start to monitor your environment more than just what are you getting escalations for. DNS response can tell you what kind of response time you're getting, or network response goes from Telegraf out to a device. So, and then the big thing, as you look at it, I strongly recommend the plugin documentation. That's something that should be side by side as you're writing your configuration for these, and look at just what are the components. It might have something there that you didn't know it could do. Just go to your favorite web browser search and search Telegraf plugins, and you'll be able to take a look at the documentation there. So a few pieces, some blog content that we've written that may be helpful in this arena with Telegraf is monitor your network, again with GNMI, SNMP, Grafana. A few of the pieces here, what built this particular session for. Then if you want to get into deeper on network telemetry for SNMP devices, we've got a section just on that. And then also the setting up of alerting, where we took a look at Telegraf to monitor your websites. So if you use ServiceNow, you want to keep an eye on the availability of the system, you may have an endpoint there that you can go ahead and pull with Telegraf. And with that, we have our contact us. We have a network automation focused Slack at slack.network2code.com. Again, Twitter is network to code on the web. And if you want to get in touch with us a little bit more, you can email us at info@network2code.com. And then I'm going to go through just a few appendix items, some of the pieces that David had in place. If you need to take a look and want to use these in your own environment, definitely feel free. So the base input configuration for R1, data normalization and enrichment for R1, and then the output for InfluxDB, and it's going to standard out. So with that, we'll go to a few questions. Just let me pull up the window here. So first question that I'm seeing here is, why is time series data important for network monitoring? David, do you want to take a stab at that one?
Yeah, sure. So the reason why is important is, well, everything that is on a network device is time series, basically. So traffic, errors, BGP messages, you want to be able to capture that in real time and have and use it to perform some troubleshooting mechanisms, also to verify, establish do capacity planning, and perform, hey, what is my fabric behaving the way it should be. Telemetry and time series database goes hand in hand in here, and it's just one part of the tool that you will need in order to work in your day-to-day operations, and also for, again, planning and design.
Yes. Next question I'm seeing here then is, how have you managed to scale out your solution? So scale, I'll take this one, and scaling it's capable of scaling for sure. We've been a part of, the folks at Network to Code have been a part of a 4,100 number of Telegraf instances that was pulling upwards of over 60,000 devices. So being able to gather the network telemetry from virtually any size network, and really being able, the pluggable nature that we have and such, that's been very helpful to be able to scale that.
Yeah, and also the thing that is important is that these tools, for example, Telegraf comes from the system from a VM perspective in order to be running an agent to gather the metrics and the health status of different agents. And on that front we're talking about a much larger scale than even the network infrastructure that we do normally have, right? And they have by default, what I think about around this is that you should think about the orchestrating solutions that actually you normally use to create these agents to establish in the different VMs or infrastructures. And you will normally use Ansible, the Terraform, or some kind of Kubernetes in order to orchestrate the assignment of these. So that way is how you actually manage to scale these kind of solutions.
Sounds good. David, this one I'm going to pass off to you as well. I see the password was in plain text for the config file. Is there any way to keep it more secure, say an integration with a secret management as Vault?
Yeah, definitely. There are multiple ways to actually achieve that. For example, the password should be, in this case, will be like an environment variable that you can actually get and store it in your configuration file. But there's also other plugins that you can use to enrich the data and perform that connection yourself. So for example, if you're using HashiCorp Vault in order to set up the environment variables for your containers, then that can be a solution. That can be a way to actually achieve that.
Yes, definitely. And then on the side of why do we pick, or the question is what made us pick Telegraf as our solution for this versus versus vendor solutions? And I think we'll both answer this one. Really is we both. Well, for me, when I look at it in Telegraf, first off, the open nature, with Telegraf itself being an open source pluggable component, and its ability to also be flexible. And so we definitely had a customer need earlier in 2020 with, in particular, looking at trying to get some metrics off a firewall that were not available via SNMP, were not available via, it does not have streaming telemetry yet. And so we wrote something that would log into the device, gather the metrics, and then go ahead and print it out. And so that would be a long-lived SSH connection into the device and get the show output. And so its flexibility and its ability to scale. Time and time again, all we see is that it's able to scale out to meet the needs of the network, whatever size it's been. David, same question back at you there of why do you pick Telegraf?
Well, you pretty much summarized it really well. The ability to also, it has a rich feature plugin system mechanisms. So you can have multiple backend solutions or different input data. In this case, we're using SNMP and GNMI. There's a couple of ways to actually achieve getting information out of a firewall or a F5 using Python and creating a script using the exec plugin. And the script is actually collecting that data and sending it back to your backend. And you grab that and use Telegraf to actually handle all the interval, the parallel processing of the data, and also all the logging. And you leverage your infrastructure on how that is going to be, trigger, how the Telegraf is going to be created, how the Telegraf is going to be configured, how the Telegraf is going to be shut down. So basically, you take advantage of the whole ecosystem when you're working with Telegraf.
Awesome. Next question coming in are what are the benefits of using Prometheus? As far as that's the two predominant time series databases that we work with and deal with are Influx and Prometheus on that front. From a benefits of using Prometheus, the one thing I'll say that has led me a little bit towards Prometheus originally, and that's where a lot of the blog posts was a little bit more of a simplified query language. with Flux that is also changing on the Influx side of things. Nothing resonates with me more of just the difference in your query language of how do you build that graph with the interface utilization. We as network engineers love the network utilization graph over time, and the Prometheus query is something with rate and the counter. And so rate is the keyword and comes out it's pretty short, pretty succinct. Whereas on the Influx DB query language side, it would be a non-negative derivative with a from and a select. So if you know SQL, I would say it marries very well towards the SQL, but I think both databases are capable for supporting time series for network devices and receiving this from Telegraf. David, if you want to go further on that.
Yeah, so basically the query language is one of the key differences between the two, and whoever you feel most familiar with to use, that will be their preferred choice. One thing that I would say is that it doesn't matter too much which kind of time series database you're going to use. It's more around the database model, the data model that you're going to use. That's the key part there. Of course, if you're a shop that is be comfortable with creating SQL queries against databases, then definitely Influx on that part is great. With Flux 2.0, that's something that is actually really interesting and to see. But also, I want to say that when you're talking about time series databases, it's important to note the high cardinality is one of the key things that you need to take account of, especially when you have a field that can have multiple values. High cardinality can actually affect performance. So it doesn't matter which type of time series database you're in, that's something that you need to take into account. Okay, so I can take this one. Does Telegraf integrate with Apache Kafka? And yes, it does provide a plugin to actually send information to Apache Kafka. And actually, that's one way to actually scale these kind of solutions for big data centers, big service providers, big networks. Kafka is a good way to actually work on that.
Yeah, I'm just double checking. I believe it supports both inputs and outputs. So it can be a subscriber to Kafka data, and it can also publish to it. So awesome. With that, another one that came in is their integration with Ntop NG. Let's take a look. So what I'm doing here as some of these come in is I'm going out to take a look at the Telegraf plugins documentation. And right now I don't see a specific one for Ntop NG, but I thought there was something with Ntop specifically on that front. David, have you seen that before?
Well, not entirely with Ntop. I'm familiar with Ntop, but I haven't seen a plugin specifically for it. Curious to see actually now. Need to do a research.
And if there's support, one of the things that came up recently on some internal discussions that someone that was just getting started with Telegraf was they want to gather some data from an API out on the web, and so they were going out and trying and working with HTTP. So if there's a API available, there's the HTTP plugin that really supports being able to gather data from various open or API endpoints to be able to put it into this whole series or into the pipeline.
Yeah, and also I would say that given a good example to if you know a little bit of Golang, Telegraf is built on Go, and you want to contribute to Go by building a plugin. They have some really good examples of how to get started. And for example, the GNMI example is a good way to see how the whole plugin mechanism work? How do you define the objects and all the other work in order to get the data out into different formats and that stuff? But definitely is worth something checking out if the plugin is not there.
Yeah, no, and in that same light with other systems, I've seen syslog for inputs, outputs, and also many other systems. I think I saw FluentD as a plugin. And so, yeah, there's quite a bit. I'm looking at the page right now. There's 197 different input plugins and 42 different output plugins. So when you're taking a look at that, that the flexibility is definitely there. So with that, I don't see any more questions. If there's any stragglers, we just want to say thank you for the opportunity for you taking a listen. Again, feel free to reach out to us. We would love to connect. And if there are any questions, with that, I think I will give this back to you, Drew.
Thank you both for the presentation and for that incredibly informative Q&A. With that being said, DZone would also like to thank both of you, David and Josh, for your great presentation. DZone would also like to thank Influx Data for providing the audience with a great webinar. Lastly, thank you to all of our attendees today. We hope you learned something new that will help you in your developer career. Have a great day.